Okay, we are back and taking a look at the 2025 Step 2, Question 1, now part double I, part 2. Let's go ahead and get started. So we are being asked to find the solutions for an expression that has the minimum in it. So we're going to end up with solutions that depend on what value of x we are plugging into this minimum equation here. So a good way to do it would be to go ahead and just remember that from the previous part, we said that we were working with x that exists from negative infinity to 0. The minimum is 2x. X that exists in the closed interval from 0 to 2. That has a minimum that is x squared. And so we need to go ahead and find the solutions based on the intervals here for the minimum function. So let's just go ahead and label them and solve. So if we are plugging in for a value from negative infinity to 0, then we know that the minimum is 2x in this case. So we plug in 2x for this value, or range of values of x. Okay. So then we're going to have negative x is equal to negative 3. So x is equal to 3. And that can be a little bit kind of weird to think about because here we're sort of contradicting ourselves. We're saying, no, x is in negative infinity to 0. But essentially when x is from negative infinity to 0, this 2 times the minimum equation just becomes a line for x. And so you're solving for the intersection between 4x and 5x minus 3. And so for that, the value in the domain of that function, that those two lines will intersect at x equals 3. Let's go ahead and take a look at behavior for 0 to 2 of this minimum function. So the minimum is going to be x squared in between 0 and 2. So we have 2 times x squared is equal to 5x minus 3. So then we could go ahead and just make this into a polynomial. And then we can solve for the roots of this polynomial. I think the quickest way, I mean, of course, you can always use the quadratic equation, but you can also use the fact that the coefficients of the second degree and the coefficient of the constant degree, if you multiply those two together, then you'll get 6. And if you add them together, actually it would be negative 2 and negative 3. If you add them together, then you get negative 5. And so this coefficient here is the same as this coefficient here. And so what you can do is just break up this expression. So you'll have 2x squared minus 2x minus 3x plus 3 is equal to 0. So that's the exact same expression, but now we can factor out. Let's say if I factor out a 3 here, then I get x minus 1. And then if I factor out a 2 here, then I would factor out a 2x, and then I have x minus 1. So then I can just factor out x minus 1 at that point, and then we're done. It's a little bit more neat, and that is something, a trick that that you can use for when the this coefficient here is not equal to 1. That's kind of a quick way of doing it. Okay, so then that means that when we're in between 0 and 2, the minimum is x squared. So then we get this equation. So the intersection between 2x squared and this line is going to be located at x equals 1 and at x equals 3/2. So those are the intersection points. And now we just have one last part to do. So we have from 2 to infinity. So we know that the minimum will be 2x, so we just really honestly just have the exact same thing. No surprise there. X is equal to 3 again. And that's really it for this one. As long as everything is clearly labeled, yeah, that covers all the cases, and that's it.